Understand Rolle's theorem with an example and try it out at the end with an exam question. I am Anil Kumar Khandelwal, author of Calculus Beyond MCV for You. Now, we have discussed many topics here which help our calculus students, especially IB and AP students, to excel. Well, in case you want to learn directly from me, you can send an email on globalmathinstitute@gmail.com or contact us on our website globalmathinstitute.com. In this video, we are going to discuss a very beautiful question based on Rolle's theorem. It's an application problem which is seen in test papers. In my book, I've discussed previous 10 years questions that will help our students to get excellent marks. The question here is list the three hypotheses of Rolle's theorem, verify that f of x equals to x cubed minus x in the closed interval minus 1 to 1 satisfies the above hypothesis, then find all numbers C that satisfy the conclusion of Rolle's theorem. Show that the function has odd symmetry. So, in a test paper, there are many questions related to a function given to us, and that is how we see in exams. So, let's go through it one by one. So, let's begin by writing what are the three hypotheses for Rolle's theorem. Now, Rolle's theorem really states that the function should be continuous within a closed interval. So, first is continuous. In closed interval, I'll just say a, b, right? Like this. And second, it should be differentiable. When it is differentiable, it means the curve is smooth. And it also implies that the first derivative is not equal to, I should say, first derivative is not does not exist or not defined, right? Or it cannot be infinity. So that means we are avoiding cusp and corner. And the third is that the value of the function at A should be equal to the value of function at B. So these are the three conditions. That means we are looking for a graph which could be something like this. So what really happens is that, let's say if you draw a line like this, right? So these 2 points here are FA and FB. So they are at the same level, right? So y equals to some value k, right? Both have the same value. Now, in that case, what happens is that we definitely have a point in between. We call that as f of c, right? Where the derivative is zero, means horizontal tangent. So when we say then find all numbers c, let me highlight it, all numbers c that satisfies the conclusion. So as you can see here, we do have a point here which is having horizontal tangent, right? So this point is c, right? So where we know that the derivative here is equal to 0. Right, so that is what Rolle's theorem is. So that is the conclusion. If we have fa equals to fb in a closed interval, then definitely there is a point which is extrema, local extrema in between that. Perfect. Now, let's do part B and say verify that this function x cubed minus x within a closed interval minus 1 and 1 satisfies the above three hypotheses. So we'll do it on a fresh page. So let's begin by taking up the function itself, which is f of x equals to x cube minus x within the closed interval minus 1, 1. Now, since the interval is closed, we know that first condition is met, right? So that is the first condition, which is closed interval. Perfect. Now, we need to find the value at the two extremes. So f of 1, let's find out, which is 1 cube minus 1, which is 0. And f of minus 1 is minus 1 cube minus of minus 1, which is also 0, right? So the second condition is also met, which is f of 1 equals to f of minus 1, right? The third condition is that it should be continuous. We know it's a polynomial is always continuous, right? So we'll write here polynomial function, correct, which implies continuous. Okay, so it's continuous. Now we have done part B. It says find all numbers C that satisfies the conclusion, right? So we basically now need to find the derivative and equate it to 0. So 3x squared minus 1. So derivative of f of x. And if we equate it to 0, then we get the value of c. So let me rewrite this. On the right hand side, I'll do split it right. And now, so we'll say f prime of c should be 0, right? And that is 3x squared equals to 3x squared minus 1. So that means what? It implies that 3x squared equals to 1, or it gives you the value of x equals to square root plus and minus of 1 over 3, correct? So that is c. So c is equal to this value of x. Right. So at this point, we have a turning point which is 0, as we have seen here. So there are two zeros within this particular interval of plus and minus, plus and minus 1. Makes sense, right? Now, part D is show that the function has odd symmetry. So let's do that. Odd symmetry also. I will, for odd symmetry, f of minus x should be minus of f of x. So I'll just calculate f of minus x. Less spaces there. You know the concept. So we'll plug in minus x for x, right? Minus x. And that gives us minus of x cubed plus of x. And this is, as you can see, we can take minus outside, x cubed minus x, which is minus of f of x. So we have shown that it has odd symmetry. Also from these turning points, you could see that it has odd symmetry, right? Now, let me just sketch it for the benefit of our viewers. Let's say we have this particular function, and that is x and y axis. It's a cubic function, as you can see. So positive leading coefficient, right side is up. So if I have to sketch, I can write down the zeros. So where are the zeros? Let me write here f of x equals to x cubed minus x. You can take x common. You get x squared minus 1, correct? Or you can write this as x times x plus 1 times x minus 1, right? You can see the symmetry of zeros, right? This, and this. From the end behavior, we know that it will kind of go like this, and linear zeros and go like this, correct? You can clearly see that these are the points where it has zero slope or a horizontal tangent line. Right? And these points are plus and minus 1 over square root 3. Clear? Right. So that is how we actually understand what is Rolle's theorem and how do we do exam style question based on Rolle's theorem. I hope the concept is absolutely clear. Try out this exam style question to confirm. In case you have any difficulty, feel free to send an email on globalmathinstitute@gmail.com. Thanks for your time and all the best.